Welcome to AD Academy. The main motto of this channel is AI for Aam Janta. My name is Dr. Ayan Debnath. I am an IIT Delhi alumni and Fulbright Research Scholar at Harvard University. I have total 9+ years of experience in the field of artificial intelligence, deep learning, machine learning, NLP, generative AI. Let's watch this video. Welcome to my metaverse. In the original paper, attention is all you need. Here this vector size or the embedding size is 512, which is very hard to show in this video. So for simplicity, let's take the size of this embedding vector as 3. So it has 3 dimensions, x, y and z, and all the words has been plotted in 3 dimensions. So here we can see the relationship between the different words. For simplicity, we have taken 3 dimensions so that I can plot this and I can show you. All the words within the sentence has been plotted in these 3 dimensions. And we can see the relationship between the words, how closely they are related to each other. Say for example, here the word man and the telescope are closely related to each other. And we can also find the angle between these words. This angle measures the distance between the words. The lesser the angle is, it means that the more closer the words are, and those words are much more related to each other, and thus it can give more weightage to those words. Once this contextual embedding is done, we also add positional embedding. So coming back to this figure, this is contextual embedding. And on the top of it, we are adding another set of vectors which is for positional embedding. Here I have drawn another set of vectors which I have represented as P of x1, P of x2, P of x3, P of x4 to mention it as positional vectors. Thus the contextual embeddings and the positional embeddings, these 2 vector spaces are being taken as an input to the encoder of the transformer. So let me iterate. First of all, the word English has been converted to a number, and this number has been converted to a vector space. First of all, it is converted to a contextual embedding, and then also with respect to the position, that is where our word is with respect to the other words in that sentence, we are also converting that into a positional embedding, that is a positional vector space. Now the contextual embedding or the contextual vector space and the positional vector space or positional embeddings are concatenated or added together, and that has been given as an input to the encoder. Within the encoder, it has self-attention model. So it means that each and every vector spaces are correlated to each other, and each of the words will understand the context and the relevance with respect to each and other words, and it has attention weights to understand or to give the importance to certain words. Not only one encoder has been used, similarly different encoder has been used here. So like this way, which are in parallel to each other. It is called as multi-head attention. Let me explain you what is multi-head attention. So say if one of the encoder is capturing some importance of the word in terms of relevance to each other, then other set of the similar encoder will try to find out the rhymes between the words. Other set of the encoder will try to find out the punctuations or in details something about the sentence. So each and every set of the encoder will extract different properties or different meaning of the sentences, that is context, relevance and all other deeper and inner meaning are being extracted from different layers of the encoders, and that is why it is called as multi-head attention. After the multi-head attention, output of the multi-head attention are converted to a vector called context vector, and this context vector has been given from encoder to the decoder.